Welcome to UPM MOOC course Technical Drawing for Mechanical Engineering. We are now in Module 5, Advanced Element in Report Drawing. This Module 5 will be divided in 3 units. In Unit 1, we will treat symbols and representations of welding. In Unit 2, we study symbols and representation of dimensional tolerance. And in Unit 3, symbols and representation of geometric tolerance. Now let's start with Module 5, Unit 1, symbols and representation of welding. What's welding? It's a fabrication process that joins metal by fusion. It needs a strong heat source, like electric gas, electric arc, gas flame, laser, and so on. Often, we need a filler material to add in the welding process. This produces an irregular union, but very secure and resilient. How is a welded part configured? Initially, we have to separate portions, like subpart, of the original part, of the desired part. Then, these portions are placed together. The representation is like an assembly, with different head patterns for each portion of the part. Finally, the welding process produces a weld bed or simply weld. How is a welded part represented? The weld beam can be represented in 2 ways, graphically or symbolically. The top view is a graphical representation where the black triangles represent the weld bed section. The group of short lines, named imbrication, represent the frontal view of the weld bed. In the bottom view we have the use of a symbolic representation. A symbol specifies the type and size of the weld. This is normally the preferred way to represent welds. Now we are going to study the principal types of welding. We have first bad welds. These are welds where the 2 portions of the part are in the same plane. The weld bit, the zone that is fusioned by the heat source, is mostly inside the portions. T of filler welds are between portions that form around 90 degrees. The bed, in this case, is mostly outside the portions. There are more types of weldings, like corner, edge, and lap, but are less frequent. Following with the principal type of weldings, we have single V, which is a full penetration welding. That is, the fusion zone have the size of the thickness of the portions that are being welded. Single V broad root. Broad root means that it is partial penetration. We have a finite deepness of the bed weld. A square also is a full penetration welding. Double V, a full penetration welding with a X shape. Single bubble. This is full penetration, like can be observed, but the question is that this type of weld needs a group which is asymmetric with respect to the portions. That is, in this case, the green portion of the welding has the group and the other portion, the red one, has no preparation, have no road. Single bevel broad root, partial penetration, double bevel, asymmetric full penetration, and others like U and W with the characteristics that we can see in the figures. The other principal type of welding is the T of fillet weld. In this case, the triangular section can be dimensioned by leg or by throat. We can have single welding or double welding for the fillet weld. Well, how is the location of the weld in ISO symbolic representation? In this example, we have a V weld that is facing up in the plane. If the symbol that we are going to use to represent lies on the continuous line of the symbol, of the arrow, that means that the weld faces to the same side where the arrow is pointing, the arrow is. In this case, and each other case, the symbol lies, in this case upside thin and bottom side thin, but lies on the continuous line, what means that the weld faces to the side where is pointing the arrow. The reverse case is if the symbol lies on the discontinuous line of the symbol, the weld faces to the opposite side where the arrow is. So in this case, these 5 representations are equivalent. This previous rule is still valid for the representation in a plan or with non-sectioned views. We have here the graphical representation. Here is the symbol lying on the continuous line, so the weld is facing to this point. In this case, we have the symbol lying on the discontinuous line. That means that the face is that the weld is facing to the opposite line of where the arrow is pointing. When we use symbolic representation of weld, we have to take a lot of care about the system of representation. That is, if we are using American or we are using European representation system. Well, for fillet weld, the same rule is applied. That is, continuous line means same side. Discontinuous line equals opposite side. These representations are equivalent. If we are using a symmetrical weld, like double fillet one, only a symbol is required, but we also can use 2 symbols, one for each side. We are going to speak now about the weld's transversal dimension. That is, if we have full penetration welds, like square, single and double V, bevel, etc., we have it's not required to establish any transversal dimension, because this corresponds with the thickness of the part. In partial penetration welds, the div must be sized by dimension in the graphical representation or by indication on the left of the symbol of the weld. We have remembered that the fillet weld can be dimensioned by leg or throat size. Location of the groove in ISO symbolic representation. We have already spoken that some welds, like bevel welds, need an asymmetric rope that affects in different ways one portion another of the welded part. In iso-symbolic representation, the arrow must point to the portion that is going to have the groove. That is, in these cases, green, and red. This corresponds to green, this corresponds to green, this corresponds to red, is where the arrow is pointing. It's the portion where the arrow is pointing. Well, longitudinal dimensions. In general, it's understood that the length of the weld is the same as the length of the joint between portions. In case we have a discontinuous weld made by n welds of length L with a gap of E between each one, the dimensions are shown right to the symbol in this format: n times L brackets E. Well, in some cases we have to indicate that the weld is around two portions with a complex profile or a simple profile, like in these cases. To indicate this situation, we have to round the corner of the arrow of the symbol with a small circle. Well, we have finished Unit 1. Let's now summarize Module 5, Unit 1. What have we learned? We learned that welding joins two portions by fusion to form a part. This procedure is secure and very used. There are many types of weld, depending on portions, relative portions, positions, the shape of the weld bed, and the groove preparation. The symbolic representation of weld is preferred due to its precision. The symbols inform about the type, shape, position, and transversal and longitudinal dimension of the weld. Well, we hope to see you again in the next unit, Unit 2.